Okay, we're going to talk about the product moment correlation coefficient and how to answer exam questions when we're doing hypothesis testing with correlation coefficients. So if you do want to skip to the part on hypothesis testing, just go to part C, skip ahead. But I'm going to do this through the example of an exam question, starting from part A here, where we have our scatter diagram and we're asked to describe the correlation. So we can see because the line of best fit goes downward slope, it's going to be a negative correlation. Please be aware, firstly, you're not going to need to describe strong or weak, just negative will do. Second thing, if it said interpret the correlation, so interpret correlation, that would mean you have to write something different. You would have to write, in this case, as, well, I don't actually know what my independent variable here is. It doesn't tell me what it is. You'd write as, I'm just going to write as x increases. Similarly, I don't know y decreases. So on a question where they would have to tell you what the actual variables were, so let's say temperature and rainfall, you would have to write as the average temperature increases, the average amount of rainfall decreases. Something like that, with the correct variables actually in your explanation. Okay, so interpret correlation, you need to give the sentence. Describe correlation, you just need to say positive or negative. If I was taking the exam, I would just write both every single time in case I get it wrong. Okay, so you're going to write negative correlation and you're going to write a sentence describing what that means. So one of them increases with the decreases. Okay, it tells us the x-axis is temperature. Using your knowledge of the large data set, suggest a variable on the y-axis and state the units that are used. And I had quite a long look into this question and discovered that I really don't like it. This is one of those where you are going to need to know a little bit of large data set. You can use a good process of elimination because this is for an overseas location first. So if you know the large data set, the overseas locations, there's actually very few variables actually recorded. Okay, so we have for overseas, I'll write them down. We have the temperature, we have the rainfall, with the air pressure, and then there's only two more. One of them is wind speed, which is given in knots, and the other is wind speed with the conversion scale, the Beaufort conversion scale. It's actually the same variable, just measured in different ways. So really, let's put the units on here. Suggest which variable is on the y-axis. Well, we know it's not temperature because temperature is on the x-axis. And it's not going to be the wind speed, the conversion scale. So this conversion scale is when it gives a description like fresh, moderate, light, whatever. That's not numerical. We can see this is a numerical variable and it's not temperature. It leaves it between just rainfall, pressure and wind speed. And according to the mark scheme, acceptable answers are, I think, rainfall and pressure, but not wind speed. And you are just supposed to know which of these variables have a negative correlation with temperature in Perth in June and July in 1987. I don't know any of the patterns in large data set. I wouldn't suggest that you spend a lot of time trying to learn all of those unless you've absolutely mastered every single other topic. I would just maybe do process elimination and guess. I did go and have a look at the large data set, and this is why I don't like the question. So I don't know if you can see here, I have air pressure, wind speed and rainfall. Now, apparently, wind speed has an ever so slight positive correlation. This is from the actual large data set. I made a graph on Excel. If you tell Excel to calculate the correlation coefficient, it does calculate wind speed. You get something like 0.15. So it's a very, very weak positive correlation. Air pressure is a weak negative correlation, and rainfall, I mean, look at rainfall here. Apparently that's a negative correlation and is an acceptable answer. It's a weak correlation, very weak. So this is why I don't like this question. Even I'm looking at this data, it's very not clear what the correlation is for rainfall. Air pressure seems to be the only one, which is somewhat clear. Okay, so suggested variable, we'll go with rainfall. We'll go with air pressure. although I would have just had to guess on the exam if I was taking it. And then state the unit. Now you should know all your units. That's a very easy mark. So the unit for air pressure, hectopascals. You can just write HPA. Okay. Let's get on to the actual hypothesis testing, part C. Staff believes there's a correlation between sunshine and humidity. So this is totally unrelated to this now. Okay, different units, different variables, different location. He calculates the PMCC. He obtains this value for R. Carry out the hypothesis test. Okay, so to explain this topic from the very beginning, you need to know what this PMCC actually measures. And this is just a measure of how strong a correlation is. Okay, so I'm going to scroll over to the side. So let me. And sort of draw this out. So when you have two variables, pen here. When you have two variables, if they are in a very nice positive correlation, so by nice what we mean, it has to be a straight line, a linear correlation, something like this. This would have a correlation coefficient of something like 0.99. Okay, so it's a number between -1 and 1, describing the linear correlation. A positive number, so this is a positive value, indicates a positive correlation, and a negative number indicates a negative correlation. So for positive correlation, the closer it is to 1, the stronger the correlation, the closer the points sit on a straight line. It does not actually matter the slope. Okay, so here, this is still a very strong positive correlation because the points are all so close to the line of best fit. Whereas a weaker positive correlation will look something like this. Okay, where when I draw my line of best fit, not all the points are right on the line. Okay, it's still pretty strong, this, but it's not as strong. And then yeah, negative correlation would be where you're going down. So I'm going to draw quite a weak negative correlation. It is negative, but there are some points which are quite far from the line here. Maybe that's a little bit strong, maybe like this. So negative 0.6 or 0.5 or something like this. Okay, so it is a negative correlation because some of the points are quite far from the line. It's not like a -1, which would be a perfect negative correlation. Okay, so to show that one, zoom out a bit here. Something like this. My two variables have a very strong negative correlation, -1 or -0.95 or something. And a 0 would represent no linear correlation. Okay, so I can't really see a pattern here. You could try and draw a line of best fit if you want. It'll probably like that, or anything like 0.1 or 0. It's unlikely to be exactly 0, but something like 0.1, 0.2. It's just it means basically there's no correlation. Last thing to explain would be if you had a relationship which was maybe exponential, or maybe quadratic, or cubic, or anything. Look how perfect this relationship is. It's not a linear relationship. So if you were to calculate the correlation coefficient, you would still try and draw a line of best fit, which I would say something like this. And then it's pretty weak. Okay, maybe 0.3, 0.4. So even a really nice quadratic relationship is a small correlation coefficient because it's not linear. So hopefully this describes what correlation coefficient is. When we do hypothesis testing with correlation coefficients, what's going on is, like in all hypothesis testing questions, we start off by assuming H0. And the H0 we assume for correlation coefficients is we assume no correlation to begin with. So you might think that, oh, then I'm going to write R equals 0. You don't write R equals 0, you write rho equals 0. This letter, rho. Okay. The reason it's a very small thing. Rho is the correlation coefficient for your whole population, and R is the correlation coefficient for your sample of the population. If you know about the sample standard deviation, it's like the difference between sigma and S. If you didn't know that, that's fine. So you write no correlation for H0, and then for H1, depending on the question, you'll either write we think there might be a positive correlation, we think there might be a negative correlation, or we think there is a correlation but we don't know which way. Okay, so just like in other hypothesis testing. And what you do is you take your data, you look at it, and then you calculate the correlation coefficient. So let's say this is my data, and I calculate, oh, that looks pretty positive. Let's say R is 0.5. The question is this good evidence that there is a positive correlation? Because as we've seen up here, even some data which has no discernible relationship, it will produce sometimes a positive correlation coefficient. That doesn't mean that the correlation coefficient isn't 0. It's just by random chance in a sample, you will get some random correlation. So the correlation does have to be strong enough to suggest that there is a correlation. So for example, if your data looked like this, you would go, absolutely, very strong evidence of correlation. That is not just random chance. And the way that you determine how strong the correlation needs to be, what kind of correlation is strong enough, it's a number we call the critical value, and that is something you just read off the table in the formula book, which I've got down here. I've copied it. So we'll go through this in the example, part C. Carry out a suitable test to investigate the claim. So we do what we said. We write down initial null hypothesis. We think there's no correlation. Alternative hypothesis. Let's see. He believes that there is a correlation. So far not specifying positive or negative. And then nowhere else does it say test for a positive or test for negative correlation. It just says test for a correlation. So my H1 will be rho not equal to 0. Now sometimes in an exam, they will give you the actual data and you have to calculate the value for R yourself, just from your calculator. So if you want a video explaining how to calculate that, let me know. In this case, they've just given us R equals negative 0.377. So what we see is some negative correlation. It's not a very strong one, yeah? It's quite close to 0. Question is this a strong enough correlation? Well, let's have a look at the critical value. So our sample size here, it says, is a sample of 30 days. That means that n will equal 30. And I need a significance level as well. 5% level of significance. Now remember, this is a two-tailed test when you have not equal to in your H1, which means you halve your significance level. So we're looking for a 2.5% significance level with n equals 30. So you go to your formula booklet and you have a page that looks like this. It says critical value is the correlation coefficient. It's right at the back. It's next to a load of other tables, so be careful there. But it should say critical values. Spearman's coefficient, you ignore unless you're doing further maths. So we don't care about that one. We look for n equals 30. The table does go a bit further down, but I just screenshot the top half. And we look for 2.5%, which is here. And where do they intersect? Here, 0.3610. Okay, so the critical value would be a correlation coefficient of 0.3610. So what this is saying is, if you had a correlation that was stronger than this, you could take that as good evidence. And if the correlation was weaker than this, it would not be significant evidence, not be sufficient. Okay, so on a kind of diagram here, you'd expect no correlation. But if your correlation is sort of stronger than 0.3610, so what that means is it's above 0.36 or below negative 0.36, because remember, -1 or negative 0.9 is a strong correlation, and negative 0.2 would be a weak correlation. Anything outside of here is a strong enough correlation. This would sort of support H1. Okay, anything in this region. Support H1, reject H0. And what was our observed value? We observed R equals, I have to scroll up a little bit. Here, we observed in green, negative 0.377. Okay. Where is this on our picture? So 0.377 is going to be, it is to the left of my critical value. It's kind of like you are here. This value here, this is negative 0.377. So because that is stronger correlation, I know the number is smaller, but it's closer to -1. It's a stronger correlation than the critical value. So I'm going to write 0.377 is less than -0.3610. Because of that, I will reject H0 and then write your concluding statement. There is sufficient evidence, and we weren't looking for a negative or positive correlation, we were just looking for a correlation. So we'll just write correlation, and the variables were, what were they? Daily sunshine and maximum humidity. So there is sufficient evidence that total sunshine and relative humidity are correlated. Again, if H1 was more specific, I would specify here negatively correlated or positively correlated. Okay, so I found my critical value from the table. I've looked at the correlation coefficient we calculated. It was strong enough, it was stronger than the critical value, so we will say there is a correlation. If we had calculated not 0.377, pretend that was 0.277, we would be in here. I would accept H0. I would say there is not sufficient evidence that there is a correlation. So hopefully that kind of explains the whole process. I mean, that's really all there is to it. Whether it's 1 tail, 2 tail, just are you a stronger correlation than the critical value? So whether that's a bigger number, if you're talking a positive correlation, or a smaller number, if you're talking a negative correlation, that's all you need to check for every single time. Okay. Let's just finish off by doing part D. Part D says comment on the number of hours of sunshine you would expect on that day. Oh, I didn't read the whole thing. On a random day at Heathrow, the humidity was 97%. Comment on how much sunshine you expect in that day. Well, we've just seen that sunshine and humidity are negatively correlated, okay, because we got a negative correlation coefficient. We got negative 0.377. So we should expect, if I had, which variable do they say first? They said sunshine, humidity. If I had sunshine, humidity, I should expect a negative correlation. Now, humidity here, it says if I saw 97%, you also kind of need to know the large data set here. This is a large number. This is almost 100%. This is above average. So if the humidity is big, so we are somewhere maybe here, that means the sunshine will be small because we are negatively correlated. So we should just say the sunshine will be less than average, and which location we're at. This is Heathrow. This is all done at Heathrow, so it's valid. This will be less than average at Heathrow because 97% is a large value for humidity, and humidity is negatively correlated with sunshine. Okay, so hopefully that explains the topic. Let me know if you want anything on a large data set or any more stats or correlation. We can go for any of that. And good luck with your revision this afternoon.